Hi everyone! Welcome to our video guide on identifying the critical path in a project network. Here's what we will do. Construct a project network or diagram. Do forward and backward passes. Determine the project completion time, calculate slack values, and lastly, state the critical path. For our diagram, we will use a node convention. Here, A represents every activity we have to do, while T stands for the expected duration or time allocated to each activity. ES is the earliest time the activity can start. EF is the earliest finish time. LS is the latest start time, and LF is the latest finish time without extending the minimum completion time of the project. Now, let's create a network or diagram from the given data or information provided in the table. Activity A can begin at the start, as it has no predecessors. Activity B and C need Activity A to be completed before they can start. Activity D and E depends on the Activity B being completed. Activity F depends on the Activity C to be completed. Activity G depends on both activities D and E being completed. Activity H depends on the completion of activities E and F. Activity I depends on the completion of both activities G and H. Since activity I has no successors, it marks the end of the sequence. Let's now perform a forward pass by analyzing a project network diagram from the beginning to the end, calculating the earliest start and earliest finish times for each activity. This process ensures that the project progresses efficiently. Identify the quickest path to completion. By utilizing the forward pass, we establish the minimum project duration and pinpoint critical milestone, enabling precise and proactive project planning. Let's start with Activity A, since it has no predecessors, so its earliest start time or ES, which gives us 0. Given its duration of 5 days, to get the earliest finish time or EF of this activity, let's add 0 and 5, which gives us 5. Activity B cannot start until Activity A has been completed. Since the earliest finish time of Activity A is 5, then Activity B's earliest start time will be 5. With a duration of 10 days, 5 plus 10, which gives 15 for our Activity B's earliest finish time. Activity C also depends on Activity A being completed before it can start. Given that Activity A's earliest finish time is 5, Activity C can start at 5. With a duration of 13 days, then, to get Activity C's earliest finish time, just add 5 and 13 and we will get 18. Activity D depends on Activity B being completed. Since Activity B's earliest finish time is 15, so Activity D's earliest start time is 15. With a duration of 7 days, we can get Activity D's earliest finish time by adding 15 and 7, which gives us 22. Activity E needs Activity B to be finished before it can start. Activity B's earliest finish time is 15, so Activity E's earliest start time is 15. With a duration of 3 days, therefore, by adding 15 and 3, we will get 18 for Activity E's earliest finish time. Activity F needs Activity C to be completed before it can start. Since Activity C's earliest finish time is 18, so Activity F's earliest start time will be 18, and its duration is 9 days. So Activity F's earliest finish time is 18 plus 9, which gives us 27. Activity G needs both activities D and E to finish before it can start, since the earliest finish time for D and B are 22 and 18. Activity G needs both of them to be finished in order to start. activity D's earliest finish time is 22. So, activity G can start at 22. In other words, the highest of the earliest finish times preceding activity will be the activity's earliest start time. So, activity G's earliest start time will be 22, and its duration is 4 days. To get its earliest finish time, let's add 4 and 22, which gives us 26. Same with activity G, activity H also has two predecessors, which are activity E and F. Therefore, we take the higher earliest finish time, which is 27, from activity F. So, activity H earliest start time is 27, with a duration of 3 days. Therefore, activity B's earliest finish time is 27 plus 3, which gives us 30. Activity I depends on the completion of both activities G and H before they can start. But since the higher earliest finish time between activities H and G is 30, which is from activity H, so the earliest start time of activity I will be 30, with a duration of 7 days. Therefore, the project completion time is 30 plus 7, which gives us 37, or 37 days. So, the project completion time is at day 37, or earliest finish time of activity I. Now that we're done with the forward pass, let's now proceed with the backward pass. To perform the backward pass, we need to start from the last activity and move backwards, identifying the latest start time or LS and latest finish time or LF for each activity. This ensures each task is completed within the project's time frame without delay. The backward pass helps in determining the latest times task can start without affecting the project's completion date. So, from activity I, since it is the last activity, the latest finish time is equal to the earliest finish time, which is 37. Since there's no successor, so we can get the latest start time by subtracting the activity time or duration from the latest finish time, which is 37 minus 7. This is because activity I must finish by the day 37 and take 7 days. So our latest start time for activity I is 30. And for activity H, the only successor is I. And therefore, the latest finish time for H is the latest start time of I, which is 30, with a duration of 3 days. So to get the latest start time, let's subtract the duration from the latest finish time, which is 30 minus 3, and we will get 27. For activity G, since the successor is I, the latest finish time of activity G is the latest start time of activity I, which is 30. Given that, activity G has a duration of 4 days. So, by subtracting 4 from 30, we will get 26 for its latest start time. Let's now proceed to activity F, whose successor is activity H. Since the latest start time of activity H is 27, so the latest finish time of activity F will be 27, with a duration of 9 days. To get the latest start time, let's just subtract 9 from 27, and then we will get 18. Next is activity E. Since it has two successors, which are activity H and G, before we start anything else, we need to make sure we complete activity E before any other tasks begin. We choose the minimum latest start time between activity G, which has 26, and activity H, which has 27. So, we need to choose the latest start time of activity G, which is 26. Therefore, our latest finish time for activity E is 26, with a duration of 3 days. And to find the latest start time, just subtract 3 from 26 and it gives us 23. For activity D, where its successor is activity G, since the latest start time of activity G is 26, So the latest finish time of activity D will be 26, with a duration of 7 days. To get the latest start time, just subtract D7 from 26, and it gives us 19. Next is activity C. Since its successor is F, so the latest finish time of activity C is the latest start time of activity F, which is 18. And activity C has a duration of 13 days. So, by subtracting 13 from 18, we will get 5 for its latest start time. So activity B has two successors too, which are activity D and E. The minimum latest start time between activities D and E is 19 from activity D. So the latest finish time for activity B is 19, with a duration of 10 days. So by subtracting 10 from 19, we will get 9 for its latest start time. Lastly, activity A also has two successors, which are activities B and C. The minimum latest start time between these two activities is 5 that we got from activity C. Therefore, the latest finish time for task A is 5, with a duration of 5 days. So, by subtracting 5 from 5, we will get 0 for its latest start time. Now, let's determine the number of slacks or floats each activity has. The float or slack of an activity refers to the maximum duration an activity can be delayed without compromising the project's overall completion time. And it is calculated as LS minus ES or LF minus EF. So, the slack for activity A is calculated as either 0 minus 0 or 5 minus 5, which will be 0. The slack values for the other activities are as follows. Activity B has a slack of 4. Activity C has a slack of 0. Activity D has 4. Activity E has 8. Activity F has 0. Activity G has 4. Activity H has 0. And lastly, activity I also has a slack of 0. For example, activity B can start at any time between day 5 and day 9, and it can finish anytime between day 15 and 19. The project can be finished in 37 days, even if activity B is delayed for up to 4 days. Activities A, C, F, H, and I cannot be delayed at all without also affecting the project's completion time. For example, if activity A is delayed by 3 days, it will result in an additional 3 days added to the project completion time, from 37 to 40. The activities with 0 slack are called critical activities, and they form the critical path, which is the longest path in the network. In this case, the critical activities are activities A, C, F, H, and I. And that's all for today's video. And thank you for watching.